Today we're going to take a look at integrating an intelligent end plate for the CPX-AP platform into a Rockwell or Allen Bradley PLC. First, let's take a look at our hardware. I have an Allen Bradley 5380 compact guard Logix PLC. I have a CPX-AP-I network node. This is the EP version for Ethernet IP. I have two CPX-AP-I I/O modules. This one is a 4-port IO-Link master, and this is a 4 digital input, 4 digital output module connected to the new intelligent end plate. This one is the EPLI-S, and then over here I have an EPLI. Difference between the two being that this one does not have a power in connection, where this one does have a power in connection. On this manifold, I also have a 12 digital input, 4 digital output module, and a VTUX pneumatic manifold. Looking at this topology of devices, before, if I wanted to combine my CPX-AP-I network here with a CPX-AP-A platform, I could only do this through the network node. This being the network node on the AP-A system, and this being the network node of the API system. But now with this intelligent end plate, what we can do is connect my API network with the communication cable here out to either a manifold, as shown here, or just I/O modules. Or you have the option to have, as I have in this setup, I/O modules as well as pneumatic manifold. I could recreate this with this platform where I have my Ethernet IP network node on my CPX-AP-A platform. And I can go out with either this AP network connection or this connection, and I can daisy chain it out to another manifold that is spread out further on the machine. So this new intelligent end plate provides a lot of flexibility in how we want to configure a network for our system. Let's start with a Festo Automation Suite file so I can manually control this device. In Automation Suite, I'm going to go to my network scan. And here I can find my CPX-AP-A-EPLI. This is my network node. I'm going to add this to my project. While this is loading, it's going to ask me if I want to import my AP devices. My device is successfully imported, so I can see my 4-port IO-Link master, my I/O module with 4 digital inputs and 4 digital outputs, and my EPLI-S. Then I can go back to my project. Here you can see the full topology here. Now let's compare it to my live connection. So I see my network node, which I have here. My 4-port IO-Link master next to it. My other I/O module next to it. And I have this running out now to this intelligent end plate, which now recognizes that there is a I/O module next to it and this VTUX pneumatic manifold. Now let's manually toggle these devices through Automation Suite. I can click on the module, right click, open plugin. Now that the plugin is open, I can connect. I'm going to read the values I currently have on the device. And now I see the different modules within this network. I have my EPLI-S, which is this intelligent end plate. I have a digital input module that has digital outputs on it, and I have this pneumatic manifold. For now, let's try toggling some of these valves on the pneumatic manifold. Go under process data. I can write that value, toggle it off. Now let's show this again on the hardware. I'm going to turn on this valve, and you can see the light turn on here. Turn it back off, and turns off. Now let's take a look at the web server. I can either go back to my network scan and click Open Device Web Page, or I can go into my web browser and just type in the IP address. Now that I'm on the web server, you can see the same list of devices. I have my network node, IO link master, IO module, intelligent endplate, all these devices. Now when I want to integrate into the Rockwell environment, in the web server, I can go under Ethernet IP. I can either download an EDS file, which will possibly take a little more work because you have to know the exact assemblies and the IO size, or I can just download the Rockwell L5X project. Allows me to change some settings. For now, I'll keep all of these as these default settings. Click Submit. I'll download the file. You can see the file is downloaded. And I'll change this to the next step. Now that I have the L5X file downloaded, I'm going to go into my Rockwell environment and I'm going to open this. Here, I changed the name from the original to this EPLIS demo. So I will double click and open this file. Now this is finished loading, I will give the project a name. I'm going to change my version. In this case, I'm using version 35, and I'll click import. Now that this example project is loaded, let's take a look at the structure behind this project. I have my CPX-AP network node already placed in my project. I already have a defined IP address. If I open this, I define the input-output configuration. All these assemblies are already predefined with their exact sizes. So that means if I go into my controller tags, that I have the configuration, input, output, and status elements for that device. Under configuration, I have the ability to change any of the configuration parameters for every device on this CPX-AP platform. And if I scroll down, I have some configuration values for this intelligent endplate. If I open this one here, you have some statuses. The manual will describe exactly what all these mean. So this can be a little confusing to use, just a large array of inputs and outputs. How do you know which element is what? Well, in this example project, if we go under this main program, we copy the inputs array into a custom UDT specifically for this architecture. So this is going to be the inputs, copy the status over to status array, and outputs to its own output structure. So if I go back to my controller tags, you can see these three UDTs here. So for this example, let's look at these outputs. We define it based on modules, which when I go back to the web server, I can see which module applies to what, as well as back in this project, I can also see the module name here. And if I expand this pneumatic manifold that I was talking about earlier, then I already have names for each of the coils instead of having to look through a large array. So now let's connect to this and I'll show you how this works online. You don't have to use this example project. You can copy and paste everything over, but for this, it's going to be easier if I just use this existing project. Communications, go online. I'll change the type to my controller. I can now download onto the PLC. I'll change this back to run mode. And now you can see that my IO is okay, meaning that my AP device is now running. No issues with the configuration here. And if I go back to my controller tags, and I will monitor the outputs under this VABX for my pneumatic manifold. And now I can toggle Coil 1, on, back off. Now I'll see that next to the hardware. You can turn it on. See the valve turn on. And then I can turn it back off. And that is how we integrate an intelligent end plate into an Allen Bradley or Rockwell PLC.